Hello everybody, hope you're doing well. My name is Louis Piluso. Welcome to my channel. Today I want to share with you a factory tour I made of ATC studio monitors. They are one of the most highly regarded studio monitors in the business, and they were very kind to let me go in and show me around how they make these wonderful speakers. Hope you enjoyed this video. Leave a comment if you want more videos in this style, and don't forget to subscribe. That is absolutely free. Hey guys, I'm Louis Piluso and we are here at the ATC factory. We have lovely Ben that's going to show us around and lovely Hector that brought me here. I'm very excited. This is one of my favorite speaker companies and we're going to learn how the speakers get made.
Welcome to drive unit production building. So this is where, I suppose this is where all the speakers start their life really. Right. So in this building we wind the voice coils, the loudspeakers, and then assemble them from voice coil level all the way up to the finished drive unit components, including test. So we'll start here, coil winding. So this is the voice coil winding room. You know, a loudspeaker, a moving coil loudspeaker is, if you sort of boil it down, it's got a motor at the center of it. Instead of a rotary motor, we've got a linear motor, and we need to wind the voice coil for the drive unit, and that's what takes place in this room. So upstairs we've got our wire stock. Stock about 20 sizes of wire to cover all the different drive units we make, from legacy PA drive unit from the 70s and 80s through to, which would make, you know, with a heavy wire, right through to a very fine wire we use on the 16 ohm mid-range that we make now. Coil specs are up here. So we select our wire for any given drive unit over onto this machine, and this is where we roll the wire down into a flatter profile. So all the voice coils we make are edge wound ribbon, and by that, if we take a coil off the shelf, here we go. If we take a cross section through coil, conventional winding with round wire, because the round wire doesn't tessellate that well, we get these gaps in between the windings. And if we roll the wire down into a flatter profile for a given length of coil, we can fit more copper in the gap. So we get a little improvement in efficiency. We can change the electrical parameters slightly by using this winding method, and we get a small thermal improvement as well, because speakers are really inefficient, and any air or adhesive that's locked in around the coil will reduce the rate at which the heat escapes. I mean, a big loudspeaker is going to be like 1%, 1.5% efficient at top. So most of the power from your amplifier just, you know,
gets lost.
It's just turns to heat. The problem with that, you know, obviously wasting energy is not good, but there's a second issue, is that as the coil gets hot, its resistance changes and its electrical parameters change. So what happens is, if you drive listening at low level and then you suddenly turn the volume right up, a speaker with poor, you know, thermal management will get hot very quickly and will change very quickly, and the sound will change dramatically. So by trying to maintain as consistent temperature as possible, the speaker will actually be more reliable and it will sound more consistent over a wide range of listening levels. So we flatten the wire down on this machine, so we can adjust the clearance here. There's two hardened steel rollers inside, so round wire this side. Adjust the clearance, check it with the micrometer, and then we can wind off as much wire as we need to do a batch of voice coils. Wow. And then wire comes over here, loaded up here on these bobbins, through the tensioners, and then we've got the winding heads here. So we've got 3 winding machines, each winding machine's got 3 heads, and then we can set these up to wind all the different sizes of voice coils. So we do 45mm, 50mm, 75mm, and 100mm. And the larger the voice coil diameter, the more surface area we've got, and the better the power handling.
How many do you produce a day or a week? How do you
we tend to sort of like do a batch run. Yeah. So they'll probably wind sort of 50 to 100 coils. Coils are small and they don't take up too much room. So we might, but then drive units we'll probably do in 5s, 10s or 20s. Coils will do more like 50s or 100s. That's part finished coils. These heavy steel parts in the center, these are what we call mandrels. So these are pieces of tooling we have made for us. So they're machined, case hardened, and then ground down to finish a tight tolerance. So they're really accurately, perfectly cylindrical, and very accurately machined to length as well. So they make sure that the diameter of the coil is very accurately set. secondary benefit is that we can then use these pieces for jigging and fixturing further down the line. So when we start assembling them, they can hold the coil in a precise position whilst we bond the rest of the parts on. So we'll go out here next. We're going to have a look at that. So the wound coils come over here, and then we've got Coil QC in processing. So we need to check the voice coil, check the windings good, because we're winding the wire on its edge,
Right.
and balancing it on its narrow edge. And of course the wire wants to fall over and sit on its wide edge. So we've got to check that they wind well and they're densely packed together.
Right.
Got to check. We've then got to size them down to the right length. Coil sizing gauge here. So that's
What's that for?
first setting the length.
All right.
And then once we've set the length, we need to check the DC resistance. So we've got a low ohm meter somewhere. So once we've sized them down, we need to check the resistance of the coil.
That's very interesting.
And if we can hit those two specs, the winding's good, we can then paper the coil. That's what's taking place here. So we laminate layers of Nomex and craft paper onto the outside of the voice coil former.
Yeah.
That gives the voice coil assembly itself more strength and stiffness, and gives us a nice substrate to bond the rest of the assembly onto. And then finally we need to cook the coils.
Yeah.
Yeah, into the oven.
Right,
Baking time.
baking. See?
So the adhesive we use is a thermosetting adhesive, and it needs to get just like you're sort of firing a pot. We need to cure it.
Yeah.
And
What
then
temperature is it?
200
Wow. Yeah.
for a couple of hours, and then that cross links the adhesive, and then that's permanently bonded unless it is elevated to a really high temperature.
Right.
So beyond, if your coil fails, if someone burns out their voice coil, blows their speaker, typically they put enough power into it that it gets hot enough that the insulation on the wire starts to break down, and or the adhesive holding it together starts to break down, which is going to be sort of 250 plus.
Right. So you have to change the whole thing.
It's hot.
It is hot, yeah.
Yeah. And then finished coils ready for the next stage of processing over here. So you've got a range of different specifications depending on the drive.
Depending on the drive, then it's ready to go.
Exactly. Yeah. So you can see they've already got a note on them. So that's 6 ohms CLD, and that's the drive unit variant it goes in. So next step is we'll start fitting the rest of the drive unit software components onto the voice coil. Hiya. Hi Wendy. How you doing? All right. So we've got some 45mm coils here from the CLD base driver. So a couple of steps further on, cone's been bonded on.
Wow.
Stiffening and damping compound applied to the rear of the cone. That's a water-based polymer. A couple of stages further on, rubber surround's been bonded on, and the spider's been bonded on.
So nice to see them like this in this stage.
So Wendy's applying the adhesive at the moment for the rubber surround. So we've got a glue dispensing system here. There's the little box over the far side, which is a timer. And when it's got a little foot pedal, so we can dose the adhesive on to make sure there's not too much, not too little.
It's so steady hand, isn't it?
Yeah.
Steady, totally. And then take the dried coil cone assembly, drop it into place, check that it sits down.
Yeah.
And then there's one more top coat.
I love seeing how speakers are made.
And then the magic finger.
The magic finger, you see?
You don't get more one in love than that.
No, not at all. So that was a bass mid driver that goes in a two-way speaker. If we come down this way a little bit. Okay, these three benches here is where we put the mid-range drivers together. So the mid-range driver is responsible for the mid-band. And in our loudspeakers, that's from about 400 hertz to 4 kilohertz. So sort of lower, sort of female vocal range. These are the coils. And then this is a partially finished software. So it's 3-inch diameter part, 3-inch diameter voice coil. So it's got a really large voice coil for a mid-range driver, which gives it really good power handling, and also means it suffers from very little power compression.
Yeah.
Because your speaker will actually, people in the studio are trying to make judgments on dynamics and compression. Well, the speaker has got compression mechanisms within it. So it's really important for a studio monitor that we minimize the mechanical and electroacoustic compression in the system, so that what you hear, you can
That's actually what you
translate.
Yeah.
This software is used in the SCM25, 45, 50, 100, 110, 150, 200 and 300.
Cool.
Yeah. The software, the dome coil assembly, goes across all those models.
Yeah.
But then there's actually 2 versions of the finished drive unit.
Nice.
So far we've been looking at the software. That's like the moving part, if you like. The voice coil, the cone, the diaphragm. But we need some hardware as well, so we need a permanent magnet system.
Yeah.
So in this area here, we put together the loudspeaker motor assemblies. These are the super linear motors for either the 6, the 9, the 12 or the 15. These have been assembled, bolted and bonded together, and they're awaiting magnetization. So one thing that everyone's always surprised by, nothing's magnetized. Of course, assembling a pre-magnetized magnet with a great big lump of steel will be extremely difficult.
Wow.
So here's a raw magnet. That's our raw ceramic magnet. But it's got the potential to be a magnet.
Yeah.
But at the moment, all of the domains within the magnetic domains in the material are all randomized. They're not all lined up.
Can I do this one?
Yeah, magnetize that one, Charlie. So we need to magnetize it. Drop the assembly into the magnetization jig. Clamp it down.
Yeah.
Okay.
Hit the initiation button.
Right.
So it's charging a massive power supply. And then it reaches about 1500 volts and it releases an impulse into a coil. So there's a coil under here.
Wow.
You can't see, but it's hidden underneath. And that coil creates a concentrated magnetic field here, and that gets everything in all the material, the steel and the magnetic material, aligns all the domains, and then it's permanently magnetized. This is the old one.
It's about 50 years old.
This was with ATC since the beginning, but it was getting a little unreliable. We kept it going as long as possible, and then we went to a new system. But
What
I think
is ATC stars?
74.
74.
Yeah. So in we've had this machine so long. We contacted Hearst Magnetics, who are still going. They're based down in Cornwall.
The collector's item.
Yeah, there was no one left at the company who knew what it was.
Belongs in the museum.
Yeah.
Yeah.
So, and this is like a dedicated loudspeaker magnet charger. So.
Wow.
And
It's a piece of history, isn't it?
it is, yeah. And this is the coil, and then the electronics are underneath. I mean, the modern system's not so different, except that the electronics are now in a separate cupboard, and this is the coil fixture. So it's just separated the two. And this approach offers a bit more flexibility, and we can have multiple coils. Because if you're doing a very small motor assembly, you need a smaller coil. If you do a really big assembly, you need a bigger coil. And if you try and magnetize a tiny coil in here, then you won't get as high efficiency. You're wasting a lot of energy because it's just filling space. So you can see we've got a smaller coil here for smaller assemblies. On this bench here, the software, the cone coil kit and the hardware come together.
Wow.
So we've got the motor assembly. It's got a basket or a chassis bolted onto it, and now we're fitting the software into the motor assembly. Get it roughly centered. Make sure that the braid wires that connect to the voice coil are lined up with the input terminals on the chassis, and then we put the spacers in. So the spacers run down the inside of the voice coil and the outside of the pole on the motor, and that centers the coil assembly. And then we just make sure the glue's evenly spread, and then we'll leave that for about 10-15 minutes to go tacky before we press it down.
Right.
It's a contact adhesive, so.
Yeah.
Okay, come this way. We've got a test chamber. So this is where we test all of the drive units. So we do a 100% test of all the loudspeaker drive units before they go over to the other building to be assembled as systems or to be sent out as spare parts. So we've got a manual test station here. See if we might as well fire it up. Let me see. So we can test here. So we've got a sine wave generator here, so it generates a pure tone, power amplifier, speaker. So using this system, we can listen for defects. Let's turn the voltage down, because that's pretty spicy.
Wow.
So we're just firing. We don't use a musical signal because music's busy and complex signal, so it's harder to hear if anything's wrong. So this is just a pure tone, and then that's 10 hertz, and we can sweep through the operating range. And you can see that there's not.
Start hearing.
But you can also see, if you look down the gap there, so you can see there's not much clearance between the inside of the voice coil, the aluminium tube,
No.
and
So it has to be.
it has to be cock on.
Otherwise, it would sound horrendous.
Yeah, if you get a tiny little bit of dirt or anything in there,
You'll hear it
instantly. Yeah, so that's what we're listening for here. Also, if it's been assembled slightly out of square, as it moves further, it might be fine at a small movement. As it moves further, it's going across the gap rather than moving perfectly parallel to the gap. So we can sweep through the operating range here. Go a bit like Star Trek.
Yeah, exactly.
We drive it a bit, in real terms, we drive it much harder than that and stress it. We get some heat into the coil, because the coil, as it heats up, it expands slightly as well. Make sure there's no rub and buzz. And we've also got a digital test system over here that we use for the mid-range drive units. It's not running at the moment, but we've got a test box here, lined with sound absorbing material. And if you look inside, you'll see a little 1/4-inch test microphone.
Oh yeah.
So we can load the mid-range drivers in, and then the computer runs the Clipple production analyzer, and it runs through a sequence of tests, and we can characterize the response of the drive unit. We can look at its impedance, its electrical parameters, frequency response, distortion, and then we can log the data. So it's a finished drive unit.
Oh, nice. So that's
keeps it clean. Once it's finished here, they might go onto the shelf, be stored for a little bit, and then we move them over to the other building in batches. Hello. All right.
Hi, how you doing?
So this is the tweeter production room. So this room's dedicated to assembling the high frequency drive units, or the tweeters. So the tweeters, or high frequency drive units, are the drive unit that's responsible for the highest frequency range, typically from about 2000 hertz up.
Right.
So typical crossover frequency for a two-way is about 2.2k.
Yeah.
And for a three-way, about 3.5k. So we're just working on glue dosing. So the adhesive on the tweeter has to be very accurately dosed onto the assembly. With the base drivers, your total moving mass might be 20, 30, 40, 50 grams.
Yeah.
You can comfortably apply the glue without much error. The total moving mass of the tweeter is 0.6 of a gram. So the difference between slightly too much and too little could be a significant percentage of the total, and suddenly you lose all the high frequency response, or the whole sensitivity of the part. So the heavier it is, typically it'll have a bigger effect on the high frequency region, and the overall sensitivity of the part. So these scales we use for dosing the adhesive, and we've got a timed dispensing pump to dose the glue. But yeah, the amount of glue for a standard coil, we're dosing 0.0195 to 0.02 grams.
Yeah.
Of adhesive. Yeah. And lots of climatic factors affect. So if it's cold, the glue's thicker. If it's warm, the glue's runnier.
I can imagine.
And as you...
It's Friday.
It's had enough.
It's thicker in the machine as well.
Oh.
Just like next door, test chamber, we've got another one here. Very similar setup, but it's higher frequency, not quite as high SPL. We use a smaller test box.
Yeah.
But we load all the drive units in here and we can characterize them all. And then finished parts, once they've been tested, there's a batch.
Beautiful. I mean, what a thing to make.
I mean, a few different versions for different models, and then a different version here with a slightly smaller motor system. So that goes in the SCM 12, 7, 11, 12, 19, and 40. Those are complete parts, and that's the moving part. So there's the voice coil. These are the only coils we don't make in-house because we can't deal with the fine wires on our machines. But yeah, there's about 40 turns of wire on that coil. 2 suspensions, so it uses 2 suspensions, our tweeter, an upper and a lower suspension.
Yeah.
That helps to maintain pistonic motion of the driver up to higher frequency and at higher power level. This whole assembly we make here. The coils are made by a supplier for us in Thailand called Aton. Makes superb voice coils. That's all the drive unit production. So once the drivers are finished, they go over to the other building. And then in the other building, we've got electronics and final assembly.
Right.
Okay, so this is the newest space production area commissioned in the building. So this is for surface mount electronics. Historically, we've always built through-hole electronics, but 12 months ago, we invested in surface mount pick-and-place machine. So if we come over here, so the through-hole the PCBs with through-hole technology, we've got, this is our circuit board, holes in the board, and the components, the capacitors, the resistors, the inductors. The legs go through the board, and there's tracks on the underside, ground plane on the top. And this is ideal for the high power electronics, the larger components for power amplifiers, etc. But as time's gone on, we need to start moving towards surface mount. Through-hole components are getting harder to get, and there are some advantages with surface mount. In addition to it being quicker, we can also reduce the size of space the circuitry takes up, so we can get more in less space.
Right.
It's better at high frequency. You've got shorter track lengths. So this is a new prototype circuit assembly. And these are the surface mount parts. So instead of there being holes through the board and the components with legs, the components have a little metal cap on either end of them, and they sit on the surface. Robot places them. And instead of the solder being a solid material that's applied afterwards, the solder is actually the first. Adding the solder is actually one of the first processes. So for surface mount, we use solder paste. So this is like a flux or a resin with lots of tiny microscopic balls of solder in it. It's a bit of consistency of like window putty. Right, so we screen print onto that board through these laser etched screens the solder paste. Now this paste has got two jobs. Initially, during the component placement stage, it acts as an adhesive, so it's sticky. So you have a little blob of this paste on each of these pads where these components are going to go. The pick and place machine places the component and it sticks to the solder paste. It places all the components. We then take the board out of this machine carefully, and then we transfer it to...
Toaster.
It is the giant hotel toaster.
It's a giant toaster, isn't it?
Yeah, conveyor belt here. And then we've got a 5-zone oven. So I'm sure you could set it up to make the world's most perfect toast, because you can independently control all the different heat zones. So
the best pizza.
Exactly.
Yeah.
In basic terms, it ramps up. We've got zone 1, 2, 3, 4, 5, and it ramps. We've got a specific temperature profile for this that the manufacturer or supplier of the solder paste has developed. So different solder paste from different manufacturers, different component sizes may need a slightly different temperature profile. This is still in the commissioning stages, we're still in the testing stages with this because it's new technology. We've used surface mount for quite a long time on some of the hi-fi products with digital features, but we'll bring it in-house. We've got a lot of testing to do before we're absolutely comfortable that we can start using it in production. So it's all got a 3D printer. It has a 3D printer. Yeah, this is the 3D printer. So it's just some prototype parts. This has been a brilliant addition. We bought it for R&D, for research and development, but we've actually used it for a lot of production tooling. So in the drive unit building, for instance, they'll need a little jig to hold something whilst they're doing one of those gluing operations. And you can chat with production, sketch it, transfer it to CAD, print it. And I mean, literally, you have the conversation on Tuesday morning, and on Wednesday morning, you've got a prototype, and they can try it in production.
Oh, wow.
It's brilliant.
I mean, that's...
So there's those parts, and it prints pretty quickly. So, and that's the filament here on. So the filament just comes on a reel. Filament comes off the reel up through these tubes, and then you've got the two print heads, and it heats it up, and then just puts it down a layer. Up a tiny bit. It's sort of working in layers of about 1/10 of a millimetre. Right, come through, we'll go. So that was surface mount electronics. We'll go to the main part of electronics now. So this is electronics assembly and test. So we're going to go upstairs where we do the PCBs. Hi, Sarah. All right.
Oh, hello.
Hi.
This is through-hole circuit assembly. So Sarah's working on solder side at the moment. So these frames hold the circuit boards. We load the board in. On the other side, we have the frame flipped over. We can load the components in. We start with the smallest component, normally the resistors or the small signal diodes.
Yeah.
Load all of those in. This foam pad goes into place, holds them in, flip the frame over, and then solder that batch of components in, trim the legs, and then we'll flip the frame back to component side, load the next batch of components, and then repeat until we've got something that looks like something like that.
Oh, that's cool.
Wow. So that's a power amp output stage. So this is the small signal section here. Input, bias, control, And then this is the power amplifier here.
Wow.
So larger components, big metal surface area on the output transistors. This is so that we can get the heat out of them.
Yeah.
Again, just like the speakers, there's efficiency losses within the power amplifier stage as well, and it's critical that the output device temperature is regulated.
Yeah.
If they get too, at the extreme end, if they get too hot, they go bang. So once the PCB's been assembled, they come down here, and then we've got an electronics test station just here.
Ooh.
So we've got audio precision analyzer, test suite, and we can run through a batch of tests for the sort of bare circuit boards. So at board level, we can complete a test here to give us sort of 90+% confidence that the part's working perfectly before it goes downstairs for mechanical assembly. Because if there's going to be any rework needed on the board, maybe someone's put the wrong resistor in the wrong bin, and that, the incorrect component value has been put in, we can fix it here at board level before it's assembled, and so it's a more efficient way of doing things.
So there are several testing points along the way.
Exactly.
Really nice.
So once those have been tested, they go into these little hods, and then we can take them downstairs. So down here we do the mechanical side of electronics. So the circuit boards come down, get assembled with the chassis that support them. We prepare transformers. So these transformers have had the wires, primary side of the wires trimmed to length, secondary sides platted.
Yeah.
Ready for assembly. Got some finished amplifiers down here. So that's the amp, what we call the amp pack, that's fitted to an SCM50, SCM100, SCM110, SCM150. So that's the transformer. So primary here, so your mains input is here, switch, fuse, into the transformer.
Huge transformer.
And then we've got two primaries, so we've got 215 volt primary, so we can configure it for 230 or 115 volt use.
Cool.
There's a 100 volt tap on there as well for Japan. And then on the secondary side, we've got output for the bass channel, output for the mid channel, output for the high frequency channel, and then the 12 volt supply here, which runs the signal processing section, the crossover filters and input stage. And there's adjustments within the amplifier that means we can configure it for the different models that it's fitted to. So next stage is final test for electronics. So we've got 3 test stations where we can test the finished assemblies, 3 audio precisions. So the audio precision analyzer can characterize non-linearities like distortions, the frequency response, the gain. We can check the shape of the filters, check the filter response is the right shape, cross over at the right point. Once they've passed that, they go onto these racks or onto the shelves for soak test. So we power everything up for a couple of days, run some signal through it, and then if nothing's gone wrong during that time, they again go back on for a final check.
Cool.
And then if it's a standalone piece of electronics like a power amplifier, it would get packed. Or if it's an amplifier for an active speaker, it would go next door into final assembly. And that's when the cabinet, the drive from our cabinet facility in Evesham, the drive units from the other building and the electronics all come together. So final assembly. So we've got these 2 big benches and then a smaller bench here. And I mean, what we're building at any one time, it can vary massively. So today we've got a load of hi-fi SCM100s, got a pair of active 40s here going through in white, a small batch of SCM19s, some 12-inch subs, the SCS70 over there, and Barry's just doing final test on this SCM100. So for the active speakers that we specialise in and we've manufactured since the mid-80s, there's a final stage of test where we can match the amplifier and the drive unit components.
Yeah.
So that's what Barry's doing now. So we can adjust the gain ever so slightly because we can build electronics with tighter tolerance than drive units. That's pretty much a given. But at final test, we can adjust the electronics slightly to adjust for any little differences in efficiency of the drive units and optimize the response of the speaker. So one advantage of active over passive is that if you compare, say, a dozen active speakers and a dozen passive of the same model, you can achieve a better consistency of sound with the actives.
With the actives.
Right. So same system as the other side for test. Microphone here. Computer runs through the test tone, compares it to a reference file, and we can then make any judgments we need on the response of the speaker.
Right.
And the lift is to get it up off the floor. If you measure them on the floor influences the height. Yeah, same height, same distance.
And for any size of speaker?
The height varies depending on the model, but the distance is always the same. Yeah. Hopefully, we'll have cabinetry. Cabinetry are here at some point as well. That's the long-term goal. We do everything here. Yeah. Cool.
So thank you so much, Ben.
My pleasure. All right, glad you enjoyed it.